All right, so we're going to look at zeros of polynomial functions today. And so our learning goals, find real zeros of polynomial functions and find complex zeros of polynomial functions. So kind of expanding, the last few days we've been doing synthetic division and long division, finding zeros of our polynomials, but we haven't looked at complex zeros at all, so we're going to bring that into the mix today. So we have new vocabulary, and these are sprinkled through the notes. I think that's the last one. Nope. All right, so we'll have that list of vocabulary. So the first thing we're going to start off is a review from Algebra 2, the rational zero theorem. And this is a way of narrowing down. So instead of like synthetically dividing random numbers, this is going to give us a list to choose from. And so we're going to look at P are all the factors of our n constant, and Q are all the factors of our leading coefficient, and we're going to divide those. Remember, a rational number is any number that can be represented as a fraction. We need to remember to consider the positive and negative of all numbers, because even if a number is positive, it can be two negatives multiplied together. Does that look familiar? So for example 1, letter A, we have the equation x cubed minus 3x squared minus 2x plus 4. And we are going to determine, we're going to make our list of possible zeros, and then we're going to determine which ones are the zeros. So looking at our last term, we have a 4. So this is our numerator, our p's. So what are all the numbers that when we multiply them together we can get 4? -2, -2. All right. What else?
1 and 4. 2.
What else?
Wait, there's more.
The negatives too. So maybe an easier way of writing this, we have all our numbers, so instead of writing out everything, let's do plus or minus 1, plus or minus 2, plus or minus 4. So that would be our list of all our possible p's. You're with me? Yeah. All right, now let's look at our q's, all of our possible factors of our leading coefficient. What's our leading coefficient? No number there. 1. So what are all the factors that could make a 1? Plus or minus 1. So now looking at this, what are our possible factors? We have 1 over 1, negative 1 over 1, 2 over 1, negative 2 over 1, 2 over negative 1, negative 2 over negative 1, 4 over 1, negative 4 over 1. So we have all of those possible combinations. Does that make sense? Yeah. All right, so what I want you to do is in Desmos, let's graph this. So we have x cubed minus 3x squared minus 2x plus 4. And so this one, the change from example 1 is now we have a number in our leading spot. So it says list all possible rational zeros. So we're going to start the same way. So what are all of the possible factors of our constant? So here we have 15. So what are all of the possible roots of 15? Okay, I heard, hold on. Like you said 3 and 5 and 15. And I heard Sydney say I think 15. All right, so are there any other numbers that when we multiply them together we get 15? No. All right, so now let's look at our denominator. We have 2. So what are all of our possible numbers for 2? What's our factors? Plus or minus 1, plus or minus 2. So now we have 2 in the denominator. So now we're going to have some fractions. And that's okay, because rational numbers can be fractions. So now we have plus or minus 1 over 1. We have plus or minus 1 over plus or minus 2, so plus or minus 1/2. We have 3 plus or minus 3 over 1, or 3. And then we have plus or minus 3 over 2. We have 5 plus or minus 5 over 1. And then plus or minus 5 over 2. And then plus or minus 15 over plus or minus 1. And then plus or minus 15 over plus or minus 2. All right. How are we feeling about that? Now it says, then determine which, if any, are zeros. Are we going to synthetically divide all of those lists? No! You are blessed with technology, so let's utilize it. So let's graph our initial expression, and let's find one rational zero that we're going to use to test for our synthetic division. We have the water level in a bucket sitting on a patio can be modeled by the function f of x equals x cubed plus 4x squared minus 2x plus 7, where f of x is the height of the water in millimeters and x is the time in days. On what days will the water reach a height of 10 millimeters? So the first thing that we need to figure out is, how do we set up this equation?
We make 10 equal the x to the third plus 4x.
Yes.
I wouldn't figure that out. Good job.
So this is saying that we want to know when our function equals this, so we can replace the f of x. This is saying f of x equals, when does f of x equal 10 millimeters? So when does 10 millimeters equal x cubed plus 4x squared minus 2x plus 7? All right, so I want to solve this. So if I'm solving it, I want to know where those are equal. What am I really looking for? I'm looking for the factors. Where do they intersect? Where are they crossing? So if I move this 10 to the other side, this is going to equal 0, correct? Yes. So then can I find the zeros of that new equation? Will that give me that same information? I suppose. We're going to find out. So let's move this over. So to move this to the other side of the equal sign, what do? Subtract it. If I subtract it here, what do I have to do? To the right? Yep. All right, so now I have a function equal to 0. So if I factor this, side, will it give me when x equals 0? All right, so let's do that. So in order to do it, what do I need to do first? Synthetically divide. How do I know what numbers to synthetically divide by? Am I going to choose random numbers?
So you gotta do.
We can, but what happens if Desmos site goes down?
You gotta use all your technology. This gesture of taking that real personal.
So let's use the rational root theorem, narrow down our list, verify on Desmos, and then synthetically divide.